Hi, this is team 3. Uh, we made exercise 1 of activity 7 and we needed to do some information and specifications about solenoids. My team is Ricardo, Arturo, Osvaldo, and Americo. The first thing we needed to clarify or mention was the duty cycle for solenoids. A duty cycle is the percentage of comparing when the solenoid is energized compared to the total time of when it is on and off. I mean, the total time of the cycle. For example, if a solenoid is energized for 15 seconds and switch off for 45 seconds, the total amount of cycle time is 60 seconds, so the duty cycle would be 25%. If a solenoid is energized uh, in all the time, it is called a 500 sorry uh, 100% duty cycle. Solenoid is is rated at a duty cycle based on a standard temperature of 35 uh, degrees and in Celsius, and you can choose voltage to manufacture any duty cycle. This graph is for some kinds of duty cycle. For this is the duty cycle of 50%. For this is the duty cycle of 75, and this is the 25 duty cycle graph. A proportional solenoid or bulb work in the same in this way. Uh, the input signal that you give it is the amount of range of travel that the valve will work. This makes this solenoid to be a precise solenoid, and sometimes solenoids are just like simple relays, uh, and they can operate as pistons or valves to control fluid pressure or flow in some injection application. It could be a fuel injection application. But the thing is that they are precise. Latching solenoids uh, use an electrical current pulse or permanent magnets to hold up the position when the solenoid is contracted, and to release this this solenoid from the holding position, they use or the factory use the a current for for making the solenoid to go in the opposite direction. And there are two types of latching solenoids. The first is the permanent magnet, which use magnets in conjunction with the solenoid coil to maintain the position of the armature where no current is supplied. And the residual magnets, these are known like the RM latching actuators, and they offer the same benefit as the PM latching actuators that were the one that we saw before, and they consume no power, producing no heat of the current and no electrical noise, so they are kind of friendly. Uh, Now we're going to see three important specs of a linear solenoid, and these are stroke, pulling force, and relative duty cycle. Well, the stroke is important because it measures the degree of movement that the shaft of the solenoid will move. We can use a reference point of 0 when the shaft is not moving, and as stroke increases, the force of the device decreases. So that's an important consideration that you need to have. Another important spec of a linear solenoid is the force that we mentioned before. There's a security factor between the release, the pull-out force and the pulling force, and it is a relation of 1.3 to 1.5. Uh, the the pull-out force is 1.3 times bigger than the pulling force, and the force is inverse proportional to the square of the space between the magnet circuit that allows the armature to move without interference and allows the magnet flux uh, to flow without reluctance or resistance. Uh, Force can be modified with the plunger you use. You can use a conic plunger for medium large strokes applications, or a plain uh, face plunger which will apply for shorter strokes. Other important aspect that you need to consider when you will calculate the force are the real load that you're moving with the solenoid, the returning force of the solenoid, the friction forces or loads that will generate, uh, the increase of temperature, the duty cycle, and the orientation of the solenoid respect gravity because it affects also to the force. Also, an important spec for choosing a solenoid is the duty cycle. As we saw, the duty cycle is the comparison between the on time and all the time of the cycle. Uh, an important consideration is to check the data of the solenoid, which is included in the datasheet. This for protecting this actuator. Um, in here we see that uh, the duty cycle affects to protect the this actuator. An example of a duty cycle is 1 second on and 3 seconds off, which will give us a duty cycle of 20%. These are the calculations, and every solenoid has a different duty cycle, and you can manufacture it uh, if you the way you will use it. And that's all. Thanks for watching.